This video is going to introduce you to the term perpendicular and its relationship with right angles and 90-degree angles. Then we're going to also introduce two related terms, complementary angles and, to a lesser degree, supplementary angles. By the end, you should be able to solve some word problems involving complementary angles and supplementary angles. Thanks for watching, and I hope this helps. The concept of perpendicularity is pretty easy, and you probably one you know already. We would say that AB and segment LK, or line LK, are perpendicular. That is, they meet at 90 degrees, or, if you'd like, they meet at right angles. So the definition simply says if two lines intersect at right angles, then they are perpendicular. You can substitute in rays or segments as necessary, as well as substitute in 90 degrees as necessary. This is one of those definitions that you'll need to remember, so you should make a flashcard for it. The symbol for perpendicularity is this upside down T, which looks like two segments meeting at right angles. We should be careful never to assume perpendicularity from a diagram. That's something we have to be told. So we would have to be told angle LEB is a right angle, or angle AEK equals 90 degrees, something like that to indicate that the two lines are perpendicular. Okay, let's talk about complementary angles. Suppose we were given that segment GE was perpendicular to EF. We can see from the diagram that angle GEF, this right angle, which we can be sure is right because we know the segments are perpendicular, that this right angle is made up of these two smaller angles, angle GEH and angle FEH. So we can be sure that their sum is equal to 90 degrees. That makes them complementary angles. If the sum of two angles is 90 degrees, then the angles are complementary. That's a definition that you should make a flashcard for. Notice that no matter how I manipulate the relative size of the two angles, they always add up to 90 degrees. That's what makes them complementary. Now we're going to be working with some word problems in this section, and so it's important to recognize how to relate these two algebraically. We are always going to call one of the complementary angles x, and then the other angle will be referred to as 90 minus x. It really doesn't matter which one you're calling which. The bigger angle could be x and the smaller one's 90 minus x. The algebra will work out the same. But it's important to recognize every time in a word problem you see the word the angle, you're going to interpret it as x. And every time you see the word complement, you interpret it as 90 minus x. Okay, now imagine you were given a straight angle, like EGF, and there was another angle, like HGF, such that EGH plus HGF added up to that straight angle. We would call these two angles a linear pair, and they would also be known as supplementary angles. If the sum of two angles is 180 degrees, or a straight angle, then the angles are supplementary. Once again, no matter how I move ray GH, it still forms two angles whose sum is 180 degrees, and that's what makes them supplementary. Now, if we need to solve a word problem, and we need to express these two angles algebraically, we're simply going to refer to one as x and the other as 180 minus x. And you can see, given the numbers, that that's appropriate. No matter how large I make one of the angles, the other will equal 180 minus the original angle. That's what makes them supplementary. This is an important definition to memorize, so be sure to make a flashcard for it. The concepts of complements and supplements are really important in geometry. We'll see them in proofs, and we'll also see them in word problems. So to give you some help and some examples with the word problems, I've made an EduCreation tutorial showing you a complementary angle problem and a supplementary angle problem. I hope that helps. Thanks again for watching, and good luck.